Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to calculate one-sided limits with trig functions involved. So the first one we're going to look at here is limit as h approaches 0 from the left of the ratio h over sine of 3h. Now, one of the famous limits in calculus is this. I'm going to write it over to the side. Limit as x goes to 0 of sine x over x is 1. And I know that that's going to be an important part of this problem. Now, when I look over here, however, we don't really have a sine x over x. We've got an h over sine of 3h. In order to use this concept, we need this and this to be the same. So if this is sine of 3h here, this needs to be a 3h right here. Now, right now it's not a 3h, but it's pretty easy to modify this so it is. I'm just going to go ahead and multiply this by 3, and then over here I'll divide by 3. Since I've multiplied by 3 and then divided by 3, I know that, that I haven't changed anything. Okay. Now, let's talk magnitudes for a moment. This now basically is this exact form, sine x over x equals 1. We're going to be careful about plus and minus signs, though. As we approach 0 from the left, these would be numbers like negative 0.1, negative 0.01, negative 0.001, and so forth. This thing's going to be negative. Sine of a small negative number is also negative. So long story short, this ratio is identically positive 1. So this part of it's plus 1. And then we have a 1/3. So the limit is positive 1/3. And that's done. I'm going to go ahead and put up a new sheet here. And I'm going to take a look at one that's got a little more going on. So I'll take a look at limit as x approaches 0 of the quantity x squared minus x plus sine x over 2x. So this has got, quite a little bit of stuff going on. First thing I'd probably recommend doing, this fraction right here we can break up into multiple fractions, and limits behave just the way you think they would. We can write this as limit as x goes to 0 of x squared over 2x minus limit as x approaches 0 of x over 2x plus limit as x approaches 0 of sine x over 2x. So what I've done is applied the limit to each of these individually. And now I'll just go through and work them out. Okay, so this x squared over x, this is effectively, this will cancel this, leaves us with x over 2. As x approaches 0, that limit is 0. Minus x over 2x. These are going to cancel. This is now just 1/2. There is no x there. It's just a 1/2. So limit as x approaches 0, 1/2. Plus. Now we'll kind of look around over here. Here's where we're going to use the famous limit of sine theta over theta going to 1 as theta goes to 0. But in order to use that, these need to be the same. I've got a 2x here and just an x. So I think what I'll do is I'm just going to take that 2 and just kind of, actually, I don't need to move it. I'll just ignore it. We're going to do this limit right there. So limit as x approaches 0, what I have kind of encapsulated in red here is sine x over x as x goes to 0. That thing in red is going to 1. And then there's a 2 in the bottom. So that limit is 1/2. And then the sum of the three limits is 0. So I'm just going to take a moment here, and I've got a crew with me here while I make this video. Does anybody have any questions about that they'd like to ask? Everything look good? This one right here. Okay, so the minus sign is coming from this minus sign. And when I broke this up into fractions, it's from this part right there, x over 2x. The x's end up canceling. So this ends up being just limit as x approaches 0 of 1/2, which is 1/2, and then it's got a minus sign out in front. You're very welcome. What do you think? All the work look good? All right, great, because now if there's a mistake, it's on you folks. All right, let's take a look at another one here. Let's take a look at one with some more things going on. Let's try this one. Limit as x approaches 0 of sine of 3x times cotangent of 5x over x times cotangent of 4x. All right, so this thing's got quite a bit going on. The first thing I'd recommend is writing all these trig functions in terms of sines and cosines. So I'm going to change this to limit as x goes to 0, sine of 3x, and then this term right here I'm going to change to cosine 5x over sine 5x, and then at the bottom x, and this term let's change that to cosine 4x over sine 4x. Now the reason for doing that, it's pretty easy to deal with sines and cosine limits, particularly when zeros are involved, because we know sine of 0 is 0 and cosine of 0 is 1 and sine of 0 over 0 is 1 and cool things like that. So shifting everything to sines and cosines. Next, let's maybe clean this up and reorganize it a little bit. So limit as x goes to 0. Let's get this into one fraction instead of this compound fraction that I've got. So the numerator here, I'm going to write that, how about sine of 3x cosine 5x and then over sine 5x. Now, remember the old saying about dividing by a fraction? That's the same as multiplying by its reciprocal, which means this sine of 4x is going to be up top. And then in the bottom, we're going to have x times cosine of 4x. So what I've done here is just rewritten it to get rid of this compound fraction, get it down into one much cleaner looking thing. All right. So now, let's see. Boy, a lot of stuff going on here. Equals limit as x goes to 0. So now I'm just going to start grouping things. I'm going to take this and group it with that x right there. Sine of 3x over x. And let's see, this stuff right here, I guess I'll group that together. Sine of 4x over cosine 4x. So this stuff is now taken care of. And then we've got cosine 5x over sine 5x. All right. Now I'm going to kind of see where I'm at here. This sine of 3x over x, I can apply the sine theta over theta going to 1 rule, but they've got to be the same. Since I have a 3x here, I need a 3x here. That's an easy fix. I'm going to go ahead and just put a 3, and I can do that as long as I multiply by 3. Right, that has not changed anything. This, oops, I changed colors here. This is now taken care of. That limit is now equal to 3 because sine of 3x over 3x goes to 1 as x goes to 0, but there's that 3 sitting in front of it. All right, now I'm going to use green here for the next term. Let's start thinking about that term right there. One possibility here, sine of 4x as x goes to 0 is going to 0. This is going to 1. I could say that's a 0 there. Let me just do that and then think about the next part. But over here, this would be a 1, this would be a 0. So that's a 0 over 0, not determinate. If we try to just put numerical values in, we're ending up with a 0 up top and a 0 in the bottom. That's not determinate, so that's not going to work. So Again, wanting to use my sine theta over theta goes to 1 as theta goes to 0. Let's do this. Let's take this term and divide it by 4x. I can do that as long as I multiply by 4x somewhere else. I'm just going to put that over there. That has not changed anything because 4x over 4x is 1. And what I know now, and I'm going to circle this in green, is that that limit is 1. All right. Now let's look right here. I've got sine of 5x in the bottom, 4x up top. So this limit isn't 1. In order for it to be 1, I need a 5x up top. So what I'm going to do is I'll just do this. I'm going to put a 5x here and divide by 5x. And now I'll do this in blue. This limit I now know is 1. These x's are going to cancel right here and here. And cosine of 5x, as x goes to 0, cosine of 0 is 1. So if I kind of go through this, this thing in red becomes a 3 because sine of 3x over 3x is 1, but there's a 3 sitting in front of it. This thing in green becomes a 1, or I should say the limit of that thing in green is 1 because sine of 4x over 4x goes to 1 as x goes to 0. In blue, we have another limit of 1, 5x over sine of 5x as x goes to 0. Don't forget there's a 4/5 right here. And then cosine of 5x as x goes to 0 is going to 1. Cosine of 4x also going to 1. So that becomes a 1. This becomes a 1. So this entire limit, let's see, we end up with 3 times 1 in green times 1 for the blue times 4/5 for this 4 and this 5. And then this guy right here is a 1. This guy down here also a 1. And when we multiply this all out, we get 12/5. So I hope this video helps demonstrate how to work one-sided limits with trig functions. Have a great day.